Welcome back to the deep dive. Our mission today is, well, it's a very targeted and high-stakes dive into the critical path of managing Salesforce.
Mhm.
We're talking about the development lifecycle and deployment architecture.
Right.
So if you are preparing to really master the concepts of structured releases, this deep dive is going to be your shortcut to clarity.
I think so.
We're not just, defining terms here. We are going to analyze the strategic decisions, the technical requirements, and the governance models you need to move change safely and efficiently.
And that's so important.
This information, everything from managing sandboxes to mastering the metadata API, it's all key to navigating those high-weighted sections of any advanced platform certification.
It's an absolutely essential mission. Deployment is where theory meets reality, and it's often where things fall apart.
Right.
You see it all the time.
Yeah.
Deployment complexity is probably the single biggest architectural hurdle for scaling Salesforce organizations.
I believe it.
And when those processes aren't structured, you get the classic problems. Metadata collisions, unexpected overwrites, just massive rework.
A nightmare.
Yeah. So today we're looking at how Application Lifecycle Management, or ALM, provides the blueprint to reduce that very real, very painful operational friction.
Okay, let's start right there with that blueprint. Application lifecycle management. It sounds a bit dry, I'll admit, but it's really the non-negotiable framework for success, isn't it?
It really is.
So what exactly constitutes ALM in the Salesforce world?
Well, you can think of ALM as the organizational umbrella. It's not just about the coding.
Okay.
It encompasses the entire lifespan of an application. I mean, from the very initial planning and requirements gathering,
All the way through.
all the way through development, rigorous testing, and then finally the release into production. It dictates the rhythm of change.
The rhythm of change. I like that.
And for a successful Salesforce practice, ALM really requires a clear release management strategy. That strategy is critical for coordinating how, when, and by whom changes are moved. It ensures everyone is synchronized.
Everyone from the business analyst defining the feature,
To the release manager pushing the button. Everyone has to be on the same page.
and the rhythm of that release, as you put it, is heavily influenced by the development methodology you choose. We've got two major approaches here.
That's right.
The rigid, structured path of waterfall, and then the more flexible, iterative path of agile.
Precisely. And they are philosophically very different. Waterfall is that classic sequential approach.
The old school way.
Kinda, yeah. You define all your requirements up front, you complete the design, then you move to build, then test, then finally deploy.
It's all in a line.
Exactly. It's linear. The major benefit there is predictability. It works best when your requirements are extremely static and well-defined.
So when you know exactly what you need from day one.
Right. And when you have rigid compliance needs where, documentation and stage gates are non-negotiable, think of these massive, multi-year, highly regulated integration projects.
But the Salesforce platform itself is so fundamentally agile. I mean, it's built for rapid change, for quick configuration.
It is.
And that really favors the second methodology, agile, often implemented with Scrum.
Absolutely. Agile is designed for speed and adaptability. It uses these short sprints,
Right.
typically 1 to 4 weeks, and it prioritizes continuous feedback loops with the business.
Which is key.
It's everything. This iterative framework is highly recommended for complex or fast-changing Salesforce projects where you need that rapid innovation.
So if the business is constantly adjusting priorities based on market feedback,
Agile lets you deliver value quickly and frequently. You can pivot.
but we know the real enterprise world is, well, it's messy. And the sources suggest a lot of companies don't stick purely to one, which leads to this interesting hybrid model, water scrum fall.
That blend is extremely common. And for anyone studying for the exam, this is a critical insight. An organization might use waterfall for the initial high-level architecture design and requirement freeze.
So that's the water part.
That's the water.
Yeah.
But then they hand off those requirements to development teams who execute the actual configuration and coding in iterative agile sprints.
And the fall.
The fall often comes at the end. The final deployment and UAT phase is a massive scheduled event, much more like traditional release management.
And this hybrid approach, I imagine it really underscores why you need robust governance.
It's essential. You need clear rules, a single source of truth, and defined handoffs to manage the friction between those predictable phases and the iterative ones.
That friction point is exactly what governance is designed to smooth out. So how do we define governance here? And how does the Center of Excellence, or COE, fit into that picture?
Governance is that essential oversight structure. It's the set of policies, processes, and rules that ensure your ALM standards are followed consistently
Across all projects.
across the entire organization. It's the enforcement layer that aligns technology decisions with the business strategy. The Center of Excellence, or COE, is the governance body. It's the team chartered to enforce these standards.
So who needs to be on that COE? I imagine it has to be a strategic body.
It must be. And it has to be a cross-functional team. That's an explicit requirement to prevent silos.
Okay.
You need representation from the business side, the product owners who define value alongside your technical experts.
The admins, developers, architects.
Exactly. Without the business at the table, IT risks building the wrong thing. And without IT, the business risks creating massive technical debt.
Let's talk about the tangible benefits here. What are the high-level gains that a COE delivers when you establish this formal governance framework?
The benefits are measurable. They really come down to risk reduction and acceleration. A strong governance framework drives 4 key outcomes.
Okay, what are they?
First, it enables innovation. It standardizes the big picture, which allows dev teams to experiment faster without reinventing the wheel every time. Second, it manages compliance and risk. The COE defines and shares security and access best practices that meet regulatory mandates.
So it prevents individual teams from going rogue with non-compliant configurations.
Precisely. Third, it drives velocity. It does this by formalizing the prioritization process of the business backlog, ensuring the most valuable features get built first.
Maximizing time to value.
Right. And finally, it delivers success by promoting adoption through defined training and quality assurance processes. Governance really takes that complexity and transforms it into reusable best practices, which ultimately drives down cost.
I really appreciate how that defines the critical working partnership between the two sides. I often see confusion over who owns what in a development cycle.
And that separation of duties is core to good governance. For the certification, you really need to remember this distinction. The business should own and prioritize the backlog.
So they define the what and the when.
Exactly. What features are needed and when they are needed. IT, or the technical team, must manage the technology release management. The how, the development, coding standards, environment strategy, and promotion to production. Governance formalizes that separation.
And to make that partnership work, we need clarity on who is actually executing those strategic decisions. Let's outline the 3 essential governance roles.
Okay. First up, the business analyst, or BA.
The bridge to the business.
Exactly. The BA defines requirements, maps out the project roadmap, and looks for commonality across different departmental requests. Their strategic focus is the overall business architecture.
Making sure the Salesforce roadmap aligns with where the organization is going.
That's it. Then you have the technical standard bearer,
The enterprise architect?
the enterprise architect, or EA. The EA's role is fundamentally about technical standardization and compliance.
So they're defining best practices for things like integration, security.
The SDLC, coding standards, everything. If a developer uses a deprecated integration method, the EA is the one chartered to enforce the standard. They link the Salesforce teams to the broader corporate IT environment.
And finally, the team responsible for the execution cadence.
That would be the project management office, or PMO. The
Yeah.
PMO owns the schedule.
Okay.
They define the delivery calendar, manage resources, and set the communication strategy, which is crucial, by the way, for informing end users about changes.
And they often act as the catalyst for adopting new delivery models.
They do. They enforce that critical feedback loop between business and development to keep the project moving forward on time and within scope.
Okay, so we've built the governance structure. Now that governance body has to make some really fundamental architectural choices, starting with the org strategy, single versus multi-org. This feels like an irreversible, high-impact decision.
It is truly foundational, and the preference, almost always, is to strive for a single org.
Why is that?
Because it delivers that promised unified data view, the 360-degree customer view,
No.
and it centralizes administration, which reduces your overall IT overhead. But as the platform scales, the challenges emerge. You have the complexity of managing highly diverse business units in one space, and, crucially, the risk of hitting Salesforce platform limits.
So when does that strategic decision swing toward a multi-org approach?
A multi-org strategy becomes mandatory when the drivers for segregation outweigh the costs of integration.
Okay, and what are those drivers?
The benefits are clear. You get autonomy for distinct business units, greater control over scalability, and you avoid those platform limits we just mentioned. But critically, it is often required to address specific regional or regulatory requirements.
Like data residency.
That's the classic example.
Mhm.
GDPR compliance or regional data residency rules,
Right.
where, say, German customer data must physically reside in German Salesforce instances. That requires separate production orgs, period.
The cost of that segregation, though, must be pretty heavy.
It is. The challenge is complex integration overhead. You now have to build and maintain interfaces between the orgs, and you have the constant risk of environment drift.
Where the orgs get out of sync.
Exactly. They get out of sync on critical components, which leads to inconsistent feature releases and just high maintenance costs. Architects really have to evaluate those specific process differences, regulatory needs, and org limitations in any scenario before they commit.
Once that core decision is made, then we have to map out the environment landscape using sandboxes. The sandbox strategy is really the key to isolating work and preventing conflicts.
It is. It ensures that dev doesn't accidentally break UAT.
Right.
The goal is a clear progression: development to QA to UAT to staging and finally to production. And we have to select the right sandbox for the right phase. Refresh intervals become a massive constraint here.
Okay, let's detail those specific sandbox types. Let's start with the workhorses for individual development.
Right. We begin with Developer and Developer Pro sandboxes. These are thin copies of your production metadata structure.
So no data.
No data. They're designed for individual feature development, unit testing, and coding isolation. They're refreshed frequently, often daily, which is necessary to keep them aligned with the metadata mainline.
And the difference between Developer and Developer Pro is just storage.
Just more storage. That's it.
Okay, so next, moving into the testing cycle, where we start to need some realism.
That requires the partial copy sandbox. This one is essential for integration testing. It contains all the metadata,
Plus some data.
plus a defined selection of representative production data, which you choose via a template. This lets developers and QA teams test complex integrations using realistic data shapes and volumes.
What's the catch?
The limitation is the refresh interval, about every 5 days. So you have to plan for it. If you need fresh data, you're waiting almost a week.
And then the final gate before launch.
That's the full copy sandbox. This is reserved strictly for final user acceptance testing, or UAT, performance testing, and staging. It's a full replica of all your production data and metadata.
The closest thing to production you can get.
It is. But because copying all that data is so taxing, the refresh interval is lengthy. We're talking about every 29 days. You have to use these sparingly, only for the highest fidelity testing phases.
We also need to talk about the modern source-driven environment model from Salesforce DX.
Right, and that's where scratch orgs come in. These are ephemeral, meaning they're temporary and disposable.
Okay.
They're built on the fly, based purely on the metadata that's defined in your source control repository. They really support that modern source-driven development model, integrating seamlessly into CI/CD pipelines. A developer can spin one up, test a single feature, and then just throw it away.
Environment planning is inseparable from risk management. So what are the 3 crucial risks that architects have to identify and mitigate in this planning stage?
The first, and by far the most common technical risk, is the risk of overwrite or collision.
When 2 teams are working on the same thing.
Exactly. One team's deployment unintentionally stomps over the others, especially if they're deploying from an old, out-of-date sandbox.
And the mitigation.
The non-negotiable mitigations enforcing source control, like Git, as the absolute single source of truth for all metadata. And that has to be coupled with disciplined branching strategies to isolate that simultaneous work.
Okay, risk number 2 is platform level, coming directly from Salesforce.
That's the risk from Salesforce seasonal releases. Spring, summer, and winter.
3 times a year.
3 times a year, these automatic platform changes get pushed, and they could silently break your existing automation or custom code. The required mitigation here is to use the sandbox preview feature.
The window where some sandboxes get the new version early.
That's the one. You must use that window to run your full regression tests against the new release before it hits production. This lets you preemptively identify any fixes you need to make.
And finally, the risk that can completely nullify even the most expensive UAT.
The risk of stale test data. If your partial or full sandboxes have data that's unrealistic or trivial or just ancient,
Your tests might pass.
your tests will pass, but the deployment will fail in production when it hits real-world data complexity. Mitigation involves a strategy that guarantees representative data.
Data that mirrors the complexity and volume of production.
Exactly.
Yeah.
And crucially, to adhere to privacy mandates like EPO or GDPR, this data has to be secured using data masking, anonymization, or data thieting tools in all non-production environments. You cannot just copy production PII into a sandbox.
Right, we now move into the core build phase. As we just stressed, everything has to revolve around the source of truth. So how does the development flow practically use version control to manage that complexity?
Well, the transition from that old org-based model to a modern package-based development requires that the version control repository Git is treated as the master blueprint.
It is the source of truth.
It's the source of truth for the entire application. Developers are discouraged or ideally completely prevented from making direct changes in long-lived sandboxes outside of a defined development branch.
And that source of truth requires a strict system to handle multiple developers working at the same time. Can you walk us through a common branching strategy that supports that?
A widely accepted strategy is based on feature isolation. A developer starts by creating a feature branch off the main development or integration branch for every single work item.
One branch per user story.
One branch per user story. They commit their work frequently to this isolated branch. When the feature is complete, they submit a pull request, a PR.
And that PR is the quality gate.
It is. Triggers automated checks, and it requires peer review. Once it's approved, the feature is merged into a shared integration branch for comprehensive system testing.
And only when all those tests pass.
Only then is the code considered stable enough to be merged into the main or master branch, which represents the code that's ready for production. This ensures every line of code is trackable, auditable, and reviewed.
Moving from process to quality, how do we make sure the code itself adheres to the high standards the enterprise architect defined way back in Section 1?
Quality enforcement is really twofold. First, code review via pull requests is mandatory. That's the human layer.
Where peers manually review the changes before they get merged.
Right. They check for adherence to coding standards, they look for misdesign patterns, and they ensure the solution is robust and scalable.
And then there's the automated layer that complements that human review.
That's static code analysis. Tools like PMD or SonarQube are configured to automatically scan your Apex, Visualforce, and other components before the merge is even approved.
And this is crucial for catching technical debt and security issues early on.
Very early. For example, they'll automatically flag anti-patterns like, and this is classic, SOQL or DML statements inside a loop.
A huge performance killer.
It's a severe bulkification violation guaranteed to cause issues. They also identify security flaws. These automated checks have to be integrated into the PR process. If the scan fails, the merge is blocked.
So quality culminates in testing. And the most fundamental gateway requirement for any production deployment is that notorious test coverage threshold.
That threshold is non-negotiable. For any deployment containing Apex to move to production, at least 75% of your Apex code must be covered by unit tests.
And all tests have to pass.
And the metadata API will enforce that all tests must pass. Furthermore, every Apex trigger has to have at least some coverage. Now, 75% is the legal minimum. World-class teams are aiming for 90% plus. But 75% is the technical gate you must pass.
And what defines a truly thorough test design beyond just hitting that 75% number?
Thorough test design moves beyond simple line coverage. Developers must design unit tests to cover 3 critical scenarios.
Okay.
You have positive cases, which verify the expected outcome with valid inputs. Then you have negative cases.
You're testing for errors.
Exactly. It tests error handling, ensuring that when you give it bad inputs or an exception occurs, the code fails gracefully. You often assert that an expected exception is thrown.
And the third.
Most importantly, tests must include bulk testing, verifying functionality when you're processing large volumes of data, think 200 records, to confirm that bulkification principles were applied correctly. You should always use a robust test data factory pattern to create clean known records within the test method too.
Ensuring the test is independent and repeatable. We keep coming back to data security. We talked about having representative data in sandboxes, but how is that managed specifically in the development lifecycle?
You need a unified test data strategy, and it has to mandate data security. If a developer needs complex, realistic customer records to test a bulk update process, that data must be anonymized or masked before it ever reaches a developer or partial copy sandbox.
So you're using tools to seed sandboxes with fake but realistic data.
Right. Data that mimics production shapes but contains no real PII. This is essential for GDPR, CCPA, and HIPAA compliance in all your non-production environments.
Let's finalize this development phase by detailing the technical differences between the 2 main development models, org-based and package-based.
Okay. Org-based development is the legacy approach. The developer builds directly in a long-lived sandbox, and that org's metadata is the source of truth.
Often bypassing version control, at least at first.
Right. And deployment often relies on change sets or manual metadata API retrievals. This model really struggles with team collaboration and environment sync.
And the modern approach, driven by DX.
That's package-based development. It's enabled by Salesforce DX and unlocked packages. It shifts the source of truth entirely to the version control system.
Using those ephemeral scratch orgs we mentioned.
Right, sandboxes are disposable. This results in a modular, highly agile development structure where your releases are version packages. It's far superior for parallel development, managing complex dependencies, and enforcing CI/CD.
Now we move into the crucial deployment phase, which, for anyone studying, holds the highest weight in architectural exams. This is where we execute the release. Let's start with a comparative look at the deployment tools.
Right, the choice of tool really dictates the level of automation and control you're going to have. And starting with the simplest, we have change sets.
Change sets are everywhere, but they come with some really heavy constraints. What are their best use cases and their severe limitations?
So change sets are UI-driven and simple, which makes them fine for small, isolated administrative updates.
Like changing a few pick list values.
It's exactly. Between directly connected orgs, they require no specialized tooling or scripting. However, their limitations quickly force you to move to more sophisticated methods.
What are the big ones?
Well, they're restricted to connected orgs in the same release train. The dependency selection is manual and notoriously error-prone. And crucially, and this is a big one for the exam, they cannot deploy deletions.
You can't use a change set to remove metadata.
You cannot. They simply do not scale for enterprise CI/CD.
So for true enterprise automation and large deployments, we have to shift to the metadata API accessed via scripting.
Right, and that involves tools like the old ANT migration tool, or more commonly today, the SFDX command line interface, the CLI. These are scriptable, robust, and highly efficient for moving large metadata payloads.
And this is the foundation of all enterprise CI/CD pipelines.
It is, because it supports automation, seamless integration with version control, and it allows for destructive changes.
The deletions that change sets can't do?
Right. You use a destructivechanges.xml file to explicitly remove metadata from the target org.
And when an organization needs commercial-grade automation and, some built-in intelligence.
That's where you start looking at third-party tools like Gearset or Capado. These platforms layer orchestration and intelligence on top of the metadata API.
What do they do that the API doesn't?
They automate complex dependency management, which you have to do manually with the API. They offer enterprise-critical features like integrated audit logs, graphical rollback capabilities, and sophisticated cross-org deployment workflows. They are essential for scaling DevOps practices.
Let's focus on packaging strategy now, which is directly linked to the development model. Why do architects need to understand the nuances between unmanaged, managed, and unlocked packages?
These package types really define ownership and upgrade capability. Unmanaged packages are the most basic. They're simple bundles for one-off distribution.
Like for open source code or project templates?
Exactly. The critical limitation, though, is that they are not upgradable. Once you install it, the components become fully editable and independent in the target org. So they're pretty much useless for internal release management, where you need continuous updates.
Then we have managed packages, which have a very specific audience.
Right. Managed packages are primarily the domain of ISVs, independent software vendors. They are fully versioned and upgradable. They provide namespace isolation, which protects the ISV's intellectual property.
And they often lock components in the subscriber's org.
They do, to prevent unauthorized modification by the customer's admin. It's all about IP protection and control.
And finally, the modern solution designed specifically for internal enterprise development and modularity.
That is the unlocked package. Enabled by SFDX, they are designed to modularize those large monolithic orgs. Like managed packages, they are upgradable and support versioning. But unlike managed packages, their components are flexible. An admin can modify them in the target org if they need to. They are the ideal choice for breaking a large org into smaller, independently releasable components.
The technical foundation for all these tools rests on two APIs that are very frequently confused: the metadata API and the tooling API. What are their distinct roles?
The metadata API is designed for migrating and deploying configuration and code metadata in bulk.
So if you're moving a new custom object, a flow, a set of Apex class...
You use the metadata API. All the major deployment tools, the CLI, ANT, third-party apps, they all rely on this for full-scale deployments. And critically, it enforces the running of all required tests when you're targeting a production environment.
And the tooling API is more granular.
Much more. The tooling API is designed for working with smaller, fine-grained components and building interactive developer tools. Think of IDEs or debugging platforms.
What kind of tasks?
Tasks like retrieving code coverage results, running a single Apex test during development, or querying schema information quickly. The major takeaway for any exam is strategic. The tooling API is not used for full production metadata deployment. Its purpose is development support and introspection.
We know a deployment is rarely just a metadata push. There are always pre- and post-deployment steps. Many of them are manual or require scripting because the metadata API can't handle them. What tasks need to be executed before and after that metadata transfer?
Orchestration is everything. Pre-deployment tasks are all about minimizing conflict and preparing the target org.
So things like disabling scheduled jobs.
Right. Temporarily disabling potentially interfering scheduled jobs or large-scale integrations. You also must communicate a change freeze to the business and ideally take a fresh metadata or data backup, a rapid recovery point if you need it.
And post-deployment. What are the common required manual or scripted tasks?
Oh, this is a deep area. First, you have to activate components that deploy as inactive.
Like flows or process builders.
Exactly. Newly deployed flows, process builders, certain site settings. They often require an explicit activation step post-deployment.
Second, the critical issue of reference data. We touched on this difference between deployable and non-deployable data earlier.
This distinction is so vital for certification. You need to load required reference data. This is configuration data that drives your application logic.
Things like custom settings data, CPQ records.
Right, or country codes. The critical architectural best practice here is to use custom metadata types wherever possible.
Why is that?
Because the records of custom metadata types are deployable as metadata. You can include them in your package. In contrast, records from legacy list custom settings or custom objects require a separate data load script using the bulk API or data loader after the metadata deployment is complete. It just adds complexity and risk.
And finally, handling user permissions and initial validation.
Yes, you must assign new permission sets or profiles to users. The actual assignment of users to those permission sets is data, not metadata, and it's not deployable.
So that's another data load script.
Typically, yes. And finally, always run a quick smoke test immediately after the deployment. Just ensure basic, mission-critical functions are working, and the system is stable before you hand it back to the users.
Success isn't just a clean deployment. It's about sustained operations. Section 5 addresses how we manage releases over time. Let's compare the main release management strategies based on frequency.
Okay, we have two poles here. On one side, you have scheduled batch releases.
Bundling a lot of changes together.
Exactly. You're bundling many changes into less frequent, major scheduled deployments, maybe monthly or quarterly. This strategy is safer for highly risk-averse organizations because it allows for these massive, coordinated UAT cycles.
But the risk per deployment must be higher.
It is because the volume of change is so large.
And the other side, often enabled by robust CI/CD.
That's continuous releases. This means deploying small increments very frequently, daily or even multiple times a day using high levels of automation.
So the risk per deployment is low.
Very low, because the change set is tiny and your feedback is rapid. But this requires very strong CI/CD practices and a highly disciplined development team.
Regardless of the frequency, the environment strategy has to support both planned releases and emergency fixes. How do we manage the path for a critical hotfix?
The environment strategy must support concurrent multiple project streams running in parallel, but it also requires a dedicated, isolated path for hotfixes.
Which is an out-of-band emergency deployment.
Right. It bypasses the normal slow release train to address a production-critical bug. The strategy requires rapid testing in a staging environment and immediate deployment.
But the act of deploying a hotfix outside the normal pipeline, that creates a huge architectural risk if you don't handle it correctly.
That risk is critical,
Right.
and it relates directly to the biggest threat to environment synchronization, which is direct changes in production.
Right.
Making changes directly in the production org, even for an emergency hotfix, bypasses all your testing and version control. It guarantees environment drift.
Meaning your sandboxes and your Git repository no longer reflect reality.
And that often leads to a severe failure later when the next scheduled deployment accidentally overwrites that emergency fix. It's a classic problem.
So what is the mandatory correction process? The back promotion.
Even when an emergency change is made directly in production, it's only a temporary measure. The change has to be immediately documented.
You can use the setup audit trail for that.
You can, and then it must be mandatorily back promoted. This means the developer has to retrieve the metadata for that change from production and committed to the relevant development branches in the source control repository.
Usually the main line or master branch.
Right, and then propagated down to the development sandboxes. This is the only way to prevent that vital fix from being accidentally overwritten by the next release bundle.
Finally, for global organizations, managing consistency across multiple production orgs presents a whole unique set of challenges.
Oh, multi-org release coordination introduces massive complexity. If you have several regional production instances, say EMEA, APAC, and North America, all using a common set of features, you need a strategy to keep them synchronized.
What's a preferred approach?
The preferred approach is to use modular unlocked packages for those shared core features. This allows all the orgs to share a version common component, and then CI/CD tools become essential to automate the sequential deployment across all target orgs simultaneously. You're managing versioning and release calendars to minimize divergence and ensure a consistent user experience globally.
The sources introduce a really fascinating glimpse into the future: AI agent orchestration or agent-assisted deployment. This seems like a dramatic shift from manual scripting to autonomous systems.
It is, and it fundamentally changes the architecture. This concept uses intelligent AI agents, like the hypothetical Agentforce, to automate these complex metadata deployment tasks.
So we're shifting from developers writing brittle deployment scripts
To agents actively orchestrating the release process, interacting with language models to understand the intent of the change.
What specific capabilities do these agents bring to the deployment lifecycle that would drastically improve efficiency?
The efficiency gains are enormous. The agent provides autonomous metadata tracking, constantly monitoring version control and sandboxes to automatically report differences between environments. It spots divergence instantly.
Okay.
It can also perform dynamic deployment scheduling, determining the optimal window for deployment based on historical success rates to minimize business disruption.
And how do they improve safety compared to traditional deployments?
Safety is built in through the automation. Agents offer integrated automated rollback capabilities. They checkpoint the metadata state before deployment, allowing for an instant reversion to the previous stable state if the deployment fails.
That's huge.
It is. Furthermore, they can attempt self-healing deployments,
Does it?
applying known remediation patterns, like automatically reconciling permission differences or minor dependency issues before they even flag a hard failure.
That dramatically simplifies the user experience for the deployment process, moving away from all those complex CLI commands.
Absolutely. The user interface abstracts the technical complexity. A user could initiate a deployment via a natural language deployment request.
So using plain English in Slack or Chatter?
Exactly. Instead of needing to know the package.xml structure or CLI syntax. And for compliance, the agents enforce rigor by automatically recording every detail of the deployment, the component, the user, the time, the result, to a secure, auditable object.
Which would drastically simplify SOX or GDPR tracing.
Right.
And how do they optimize that required testing phase, which can often take hours?
They optimize the mandatory test execution. Instead of running the full regression test suite unnecessarily, agents can dynamically select to execute only the impactful Apex test classes,
Based on what's being deployed.
based on the specific metadata coverage related to the components being deployed. This saves significant time, often cutting testing cycles from hours down to minutes, while still meeting that 75% coverage requirement.
While the efficiency is undeniable, handing over control of the release gate to an abstract AI, that has to introduce new and pretty serious architectural risks. What are the key limitations we need to consider?
The risk really shifts from technical complexity to governance and control. One major risk is human layer oversight gaps.
Okay.
If the agent is too autonomous, there's a risk of it promoting wrong, incomplete, or even malicious changes without adequate manual human verification. We need human-in-the-loop governance.
And what about the inherent complexity of Salesforce metadata itself?
Agents can struggle with platform nuances. There's a risk of missing implicit dependencies. The agent might only see explicit metadata references, but miss critical complex dependencies,
Like what?
like complex sharing rules, dynamic role hierarchies, or complex flow logic that aren't clearly defined in the metadata structure. That could lead to really subtle post-deployment failures.
And when things inevitably fail, the debugging process could become a nightmare if the agent's logic is just a black box.
That leads to debugging complexity. The agent's abstract decision-making can obscure the root cause of a failure, and developers might struggle to trace why the agent chose a particular action or why remediation failed.
There's also a governance conflict risk here.
A severe one. Automated execution could violate strict ITIL or SOX requirements that mandate manual approval gates and an undeniable audit history if the agent is allowed to execute releases without very careful configuration and oversight,
And finally, these agents are trained on historical data.
which introduces the risk of training data bias. The agent's performance is limited by the quality and accuracy of the historical data it learned from, if that data is biased or represents bad deployment decisions.
The agent might just perpetuate those bad decisions.
Exactly. Plus, there's always the risk of version drift, where the agent's internal logic updates less frequently than the core Salesforce platform, causing it to misinterpret new API versions or features. Tag outro.
This has been an exhaustive deep dive, mapping out the entire Salesforce deployment lifecycle, from the governance framework that sets the rules all the way to the cutting edge of AI orchestration. For you, our listener, focusing on mastering this domain, remember the strategic takeaways.
Right.
ALM provides the structure, the COE provides the oversight, and the choice between single and multi-org determines your scaling path.
And remember the specific technical details. Use Developer Pro for isolated work, partial copy for realistic integration testing with representative data, and full copy sparingly for UAT. Crucially, the metadata API handles bulk deployments and test enforcement, while the tooling API is for developer introspection.
And never, ever forget the 75% Apex test coverage minimum.
Never.
If the sources teach us anything, it's that the barriers to success are rarely the technology, change sets or SFDX, but the process.
Which brings us to our final thought for you to consider. The material shows that the biggest barrier to rapid, safe deployment is often the lack of governance, poor communication, and the resulting environment divergence. As AI agents rapidly accelerate deployment speed, the fundamental architectural challenge shifts.
It does.
It moves from simply maximizing how fast we can deploy to maximizing trust and control over those autonomous processes. This demands a new focus on the auditability of the agent's actions and effective human-in-the-loop oversight. The future challenge isn't automation itself, but defining the governance threshold, the acceptable failure rate for autonomous deployment in highly regulated financial or medical environments.